Hey guys, today I'll be doing linked list cycle. It's considered an easy question, but I would say it's not all that easy. The thought process behind it is the most foundational one, I would say. So the pattern, you could say, is basically using slow and fast pointers. Now this is a trick I guess used a lot in linked lists, and the idea behind it is, let's say you have a friend, okay, he runs 2 times faster than you. So consider this like a racing track, okay? Your friend runs 2 arrows while you only run one. So after T1 you would be here, whereas your friend would be one ahead of you, right? And you'll keep doing this, you'll come here, but your friend will keep overtaking you every single time. And the idea is to detect cycles. There's another question after this, linked list cycle 2 if I'm not wrong. It uses the same idea as the 2 pointers approach, but the idea behind it is, if you have like a pointer that's running double of what you're doing right now, and let's say you have a circle, there will be a point in time, right? Because if your friend is going twice as fast as you can envision like F1, okay? There's like an extremely fast car, and that car is able to go like so fast that it overtakes the last positioned car. So it will basically like lap it, right? You get what I mean? It will overtake it and it will be like a lap ahead essentially, and the slow one is that slow and the fast one is that fast enough to do it. And if we didn't have that, if we didn't have it like a loop, then your friend would just go so fast that he would like be like far ahead of you. Like you'll never catch up to him, and your friend will never be able to overtake you because your paths never cross, right? And it's the same idea with linked list cycles. So if you have like a pointer, we'll call it slow, okay? Here it's set up with the head, fast, that's set up with the head as well. And while like your friend can cover the track fast and fast next so that it doesn't hit the end of the loop, we'll only move ourselves by one, but we let the friend move twice as fast as us, okay? And if there is a point, right, if there is a point that we meet, like the slow and the fast meet, it means that it's like a lap or like a loop, you could say. Like, you know how racing tracks have laps and there's loops? So basically you've hit the point where you were able to collide with each other, and this is only possible if it's like a circle or like a lap. If you had like a straight line, right, let's say you were just running a 100-meter race, your friend would essentially finish before you, and there's no point in him turning around and coming back to you and like overtaking you, right? There's no point, he already overtook you, and he's never gonna come back and do that, right? And you'll never like catch up to him, like you'll never equal him because he's already done, he's that far ahead. And it's the same idea. So if you ever meet your friend, it's basically that it is a loop because you've hit him again. Otherwise you wouldn't have hit him, because if it was a straight line and we went from this node to this node to this node to this node and this node and to null, and we can consider the null as our finishing line here. So if your friend basically just jumped twice as fast as you while you were just jumping one, right, he already reached the finishing line, but whereas you're still climbing it. But if he had like a loop, so the circle, like I said, your friend will run twice as fast, you'll come here, right, and he'll run this while you'll come here, and then you'll run one and he'll come two and then he'll catch up to you basically at one point in time. The diagram's gonna get very messy, so I'll explain it like this. He's gonna catch up to you at one point in time to overtake you, right? And that's basically the idea that, oh, so if he can overtake me, that means he went around the linked list and he came back to where I was. And that's it. So if we ever meet our friend, that means there was a cycle, and we can simply return to in that scenario. And if we never met our friend, right, like let's say the loop ended because we were only doing it till fast and fast.next. Now why fast.next? Because we're doing it twice, so we're doing fast.next, so fast.next could be null itself as well. That's why we need to check that it's not null, so that we can use the .next operator on that. And so if we ever hit our friend, we've, like, it is a loop and he's come back around to come to us. And if we never meet him, then it was a straight line and we went all the way to now. We reached the finishing line and we never met him, so it's never a loop, and that's it. Return false in that scenario. Is that simple? I mean, it's not that simple. I think this is like something you just have to understand. I don't think it will come to you intuitively, but given this idea, I would definitely recommend doing linked list cycle 2, which is a medium question now. This is, I would say, pretty tricky. This is also really hard, so if you don't get it, it's completely alright. I'll explain it tomorrow, but I would say you should do it, and then I'll show it to you tomorrow.